Hello and welcome to the session. My name is Sanjay Goil. I do product management in the database team based out of Redwood Shores in California. I'm going to talk about replacing Kafka use cases with powerful inbuilt database queues in modern applications, mainly focusing on AQ, which is advanced queuing, and the transactional event queues that are coming in a future release in the database. So let's get started. I wanted to cover industry trends, what's happening in messaging, streaming, and some of the associated areas of microservices. The Oracle Converged database, right? So if you're familiar with the Converged database, we are bringing in various data types together, including messaging and events, right? So we'll talk about that a little bit. Talk about Kafka interfaces, Kafka clients, and how Kafka has become popular. And then AQ and transactional event queues. What's in the current databases 12.2, 19, and what's upcoming in the future release later this year. And of course, we'll summarize this thing. So if you're familiar, with streaming, the Apache Kafka product has become quite popular. And as you see, it does events, but no transactions. So this got started maybe 5-6 years back at LinkedIn, if you're familiar with that. So they looked at, a database, and of course, database messaging back then didn't really treat events as first-class objects, and you needed SQL to get out of tables. So you would use a table for maybe storing events, and then kind of running your regular SQL queries for that. The second thing was, I guess, not suitable for volume of all the events that were coming. The volume was, again, very few transactional events, but a lot of non-transactional events. This is what gave rise to Kafka, and Kafka became an event streaming platform out there. But again, keep in mind that it doesn't do transactions as well, which with which what we mean is writing into a database and then also sending a message out to maybe another service or another microservice. So if you look at how Kafka is used, on the left you see a lot of data being produced by web servers, order service, APIs, mobile, IoT. Right? So a lot of transactions go into database, but events also get produced here, or data gets produced here. This data then gets into Apache Kafka, and that then gets downstream into a variety of data types. Right? You see various data bases, data stores, object stores, data lakes, and then gets consumed on the right side of things here. Right? So it could be a mobile app, search portal, ops dashboard, analytics, and other things. Right? So you can see this gets fairly complex, and people refer to this as Lambda and Kappa architecture. So many technologies, multiple data stores, data gets copied many times, and it leads to what we call copy contagion. So again, security becomes a problem, complex and difficult to maintain, and requires a variety of skills. They're fragmented across these various data types. So again, the same thing around Hadoop and stream everything are the Lambda Kappa architectures, as I talked about. So how do we simplify this, right? So question was, we can simplify this by having a converged database, right? So in the center you see a converged database, which then there's a Kafka compatible event queues in the database. So when we talk about AQ or AQ sharded queues, these are these Kafka compatible queues which are part of the database. So again, the fact that the database can now have relational data, document data, graph data, and events together eliminates a lot of the complexity. And this you can see in a better picture here, where you have a converged database, right? So the Oracle database, of course, has containers and has pluggable databases, right? So this becomes a virtualized environment, and great for modern applications, great for microservices, right? So with microservices support, open interfaces, easy apps, building blocks, you can basically have a self-managing database, with the autonomous database on Oracle Cloud infrastructure. So again, as you think about events, as you think about Kafka, the question is, where are all the events stored? Where is the streaming data stored, right? And Kafka has been evolving into a streams database, right? So again, if you are a database user, it becomes very hard for you to understand how to use Kafka, right? So Kafka uses compacted topics, which are basically events, and for any key value store, it would keep the latest key into a compacted topic, right? It's basically compacting logs in some ways, and then you can replay some of these things. So it's a very different world, which makes for more complexities in applications. We're taking some of these same paradigms and trying to bring the best of messaging, the best of streaming into what we call transactional event queues. So transactional event queues is the new name for AQ sharded queues. So I'll use these names interchangeably. So, but if you're in database 12, 2, or database 19, AQ sharded queues is the name. And if you are 20 and 21, you're basically using transactional event queues, right? That's what the APIs will be exposed. The best of messaging gives you messages, transactions, exactly once paradigm. GMS, very popular Java messaging service, and of course SQL and C and Python and other things. On best of streaming, you get events, you get pub/sub, publish, subscribe, high performance, horizontal scale, right? So part of AQ sharded queues is that it is a partitioned queue. So you take a queue table, you partition it, and then each of those partitions, which are known as shards, are addressable, right? So you can basically produce, consume, or enqueue and dequeue from each of those shards, right? And you can use any language as such. So events and transactions. So if you saw the first slide, Kafka was events but no transactions, right? So the question is, can events plus transactions at a highly scalable event streaming built into the database gives you a better advantage? Can it simplify some of your pain points, right? So of course, events on monoliths don't matter as much, right? This was what the current state of art in monoliths is, right? So you have apps, you have databases, you have a lot of relationships between apps through the database, right? So many apps can write to single database in some ways. The event-driven microservices on the right side are, you have an event platform, and then you have apps that are writing locally to a database, right? So in some ways, local transactions, bounded context, right? So we go back to understanding what microservices are, right? Which are loosely coupled service-oriented architecture with bounded contexts. And the loose coupling usually can be seen where you use a event platform or a messaging bus, or you use maybe gRPC or REST calls and other things, right? But I think messaging makes it more asynchronous in some way. So the importance of transactional messaging is also a key differentiator here, with AQ providing transactional messaging, right? So in this case, you see an example where there are two microservices, an order microservice and an inventory microservice. An order is placed, it writes the order to the database, but also within the same transaction sends an order message, right? So before this commit, this message doesn't appear here, right? So when the commit happens, this transaction receives the message here. So the order one message comes here, it checks its inventory and sends its response. And before, only after this commit does the message come back here when when the transaction here receives the response and updates the order status, either having the inventory or not having the inventory, right? So, and then the AQ takes care of message propagation between these two databases. Now, it could be that it's a single database, you don't need message propagation, right? So advantages here are to combine, the DML and events in a database transaction, guaranteed delivery of an event exactly once, and you can use these to chain workflows in some ways, right? So again, it's a smart messaging broker in some ways, and contrasts the Kafka design, where it's about dumb brokers and smart consumers. So it actually pushes a lot to the code writer, right? So the developer to figure out how to consume these messages. So transactions and events are crucial for microservices, right? So monolith applications use transactions quite extensively, and again, this whole idea, when a monolith gets split into independent microservices, there are patterns that connect these things, right? So a saga pattern is basically is an independent transaction which is local, and it of course needs compensation if there's a rollback. So you may commit a local transaction, commit another local transaction, but if the third microservice fails and they participate in this saga, then all of them roll back. So which basically is compensation, right? So you can take an example of a trip booking, and you want to, in a saga, book an event ticket to say the Olympics in 2021, or booking of a hotel, booking of a flight, right? So all these, either all of them succeed or none of them succeeds, right? Is a saga pattern, and microservices can benefit from it, and the AQ becomes kind of the messaging platform for sagas, and bringing transactions, events into the microservices field. So, of course, the Converged database, has events now, right? And this is a slightly different perspective than running specialized databases. So, if you are down the path of running specialized databases, you should consider the Converged database simplicity, and I'm sure some of this will appeal to you as we go forward. So let's look at where some of these things work in the how transactional event queues and event streaming is built into the database. It supports GMS and Kafka APIs, eliminates separate messaging infrastructure. So you can see that these microservices are in Docker containers, use Kubernetes cluster, and then they are addressing the independent. So you could do it at a PDB scale, or you could do schemas within a PDB. But a container database in Oracle can have hundreds of PDBs, right? So perhaps it's a good choice to keep a PDB per microservice in some ways, right? So again, we talked about sagas and transactional messaging earlier on. So we believe it simplifies development of fault-tolerant microservices with the ability to have an event system with the Converged database. So, of course, you've probably seen in some other database talks the fact that JSON and spatial and graph and machine learning are part of the database. We are now saying events is also part of the database with AQ and transactional event queues. So you can build event-driven, data-driven applications with the Converged database. So the benefits, of course, you can think about iPhone bringing in various capabilities together into a single device. Same way, an Oracle database, which is converged, brings in documents and spatial and graph and relational and tabular and analytical data, events data together in some ways, right? And it allows for even more types of activities to be done, right? So for the iPhone, for example, with the combination of internet and music, you can now do streaming music, for example, right? So use cases, the new emerging use cases come same way with the convergence of events with various other data types. You can think about it as a good platform for microservices in some ways, right? So kind of look at some of the other advantages of security, SQL, and simpler, lower cost, more reliable, and other things. So if you look at the various you know, special purpose databases coming together in a converged database, two advantages come out, right? One is the virtualization and consolidation of data. So there's a container database, and then these pluggable databases can consolidate, you know, your various different data types or different databases into you know, similar types of database in the PDBs. The second is the converged query, which is again the unified data model, right? So once this data is sitting next to each other, you could write views and queries in SQL, Java, Python that gives you a holistic view of your data, of all your operational data, and you can start doing, you know, more interesting analytical queries across these data sources. All right, so again, I think we're introducing what we call transactional event queues. Hopefully gave you some idea on why it is important in a modern application development environment. So, you know, provide a robust and scalable event streaming layer in the database with Kafka, JMS, PL/SQL, and C interfaces. So when we say Kafka interfaces, we mean Kafka Java client, for example, right? So if you're producing and consuming in a Kafka Java client, you can, instead of using Kafka brokers, use the Oracle database, and we'll show you in a few slides how that is done. So you can build scalable event-driven application architectures. So I think it's fairly exciting to be investing in the event layer within the database. So common use cases of event queues, you know, it includes sending, receiving a message as part of a transaction, async, produce, and consume event messages at scale, right? So you can just produce, somebody subscribes, and you can think about produce, consume, or pub sub type of a thing. Workflow coordination, AQ, is used for workflow coordination between application and microservices. And then bring events as for persistent storage. So you can also, IoT events and other events can be put on a queue to be stored into the database. And of course, messages with notifications to trigger action, messages with transformation and notification, message propagation to other databases, even remote databases, and scheduling of worker jobs for execution. So there's a lot of use cases, the traditional messaging use cases, but some emerging use cases for building eventing architectures. So the single logical queue with many event streams, right? So this basically means that the queue is a single logical queue, but you can address you know, various event streams, right? They're also known as shards in AQ sharded queues. They're highly concurrent and throughput via horizontal partitioning. Event streams are previously called shards. Event streams consist of table partitions, you know, at the database level. They're automatic in some ways, where the system partitioning of queue table for scaling out happens automatically. Space management of event streams via, you know, partition mapping operations. Load balancing of NQ sessions through event streams. So there's a lot of automation that goes on as these event streams keep on working. Dequeuing of all event streams within an instance is automatic between balancing, you know, various consumers, and cross-instance forwarding of messages when no local decoder is present. So if you are on multiple instances of a rack, then you know, there's automation where the messages will be cross-forwarded to the local decoers on the other instance. So again, it's integrated with the database to optimize performance, and then you have, you know, modern interfaces, JMS, PL/SQL, C, Python, Node.js. You know, we haven't written that here; it's missing on the slide, but those are also supported. Here's a brief history of the AQ, right? So again, it was introduced in release 8.0. So AQ has been around for a long time in the database, and it has, you know, gone through, say, several transitions. They were renamed Oracle Streams AQ, and then some of this was deprecated, and I guess there was some confusion around, you know, is AQ still around or not? But, you know, in 12C, 18C, 19C, it's renamed back to AQ, and then AQ sharded queues were introduced in 12C, which were the partition queues very much like maybe around the same time as Kafka was coming out, right? And going forward, we're renaming AQ sharded queues as transactional event queues. We added Kafka compatibility to it. Some of this work works with sharded queues as well. So again, you can run, produce, consume type of applications with Kafka Java client, which we have previewed in open source. And then, of course, Oracle AQ for single node workloads is very simple, very easy to get started on. So here are some key concepts, again, just to relate these various transactional event queues, AQ sharded queues, Apache Kafka. There's an OCI streaming service on OCI on the Oracle Cloud, and then, of course, JMS, right? So, TQ or transactional event queues creates a queue table. AQ sharded queues create a queue table, very similar to what Apache Kafka creates a topic. And queue table consists of event streams, which is a rename of the shards. And, that's similar to what a partition is in Apache Kafka or the OCI streaming service. And then these shards are built of subshards, which are, memory allocation units and other things, as Kafka has segments in them. And they're addressed by offset. Same here, there's something called offset. And in AQ sharded queue, there's something called message ID. So again, queue table is a partitioned append-only queue of messages. Event stream is an ordered collection of messages. And producers and consumers can work on multiple event streams concurrently. Right. So again, if you're familiar with Kafka, you can understand some of these things that are associated with each other. So again, there are several developer options for events from Oracle. So it may confuse you that, what should I use when? Here's a quick cheat sheet. So, if you don't use Kafka, if you use AQ all the time, or you use IBM NQ or a queuing service like AWS SQS. So queuing has always been slightly different than streaming, or you've used Kafka and found it maybe it's too complex to maintain your brokers and scale and all that. Transactional event queues are a good start, right? So, you can find them in the Converged Oracle database. They are part of the database. There's no special sauce, no special ingredients needed for it. You can get started right away. And if you're using Kafka brokers primarily today, interfaces, you want a managed service, OCI streaming cloud service is a good one. It's Kafka compatible, multi-tenant on OCI. It's a managed service. Or you could run your own Kafka on OCI. You can run Confluent Kafka on OCI with validated Terraform scripts. There's also, if you're running Kafka, Oracle SQL for OCI streams and Apache Kafka. So there's Big Data SQL and Cloud SQL, which of course, similar to what KSQL would do. And that's a Confluent add-on, not in Apache. But you could do processing of Kafka streams with SQL, with Oracle SQL through these Big Data SQL and Cloud SQL products. So here's a quick look at how produce consume happens, like in Kafka. So say suppose there's a topic here, and the producer is producing to a topic in two partitions, right? So there's partition 1 and partition 2. The producer 2 produces to partition 3. All consumers, there are 3 consumers, consume from all topics, right? So when you look at this structure, this, again, you could get a Kafka broker. So on the left side, we show that there are producers, there are consumers, and there's a broker. There's a zookeeper managing Kafka. So you can kind of spin up a Kafka cluster. So then, there's a property in Kafka Java client, which says, here's a bootstrap server, Kafka in 1992. So if you change this to a database link or a database instance at 1521, we can, and I'll show you some examples of how to do that, is to not have the Kafka Java client produce consume from a Kafka cluster, but can do it from AQ sharded queues or TEQ in the Oracle database. Right? So you can think about using the Kafka client for TEQ for that. You don't need to then manage Kafka as a separate infrastructure. Right? So again, what are the advantages here? It's simple. No separate infrastructure managed, right? I guess that's fairly obvious. It's free. It's included in the database EE and autonomous database. Easy to enable, same skills as using the Oracle database. Again, the tables are addressable. You can query the tables. Very similar to set up your HA, your security, your backups, and everything else. Secure, relies on database security model, highly available, extends messaging to streaming data and events. And of course, we have open sourced the Kafka client, like the Kafka clients. And of course, you can get high performance on RAG database, right? So if you're using Exadata or ExaCS cloud service, you get high performance out of the box. So here's a Kafka producer example, right? So you can see, pretty much the same code that you would use, right? So this is a Kafka example where Bootstrap servers are at port 1992 for a Kafka broker, and then you do a producer dot send, right? So you're sending 100 messages, for example, here to my topic in some ways, right? So if you take this producer example in Kafka and you want to write it as a producer client, one change you want to do is to get the Bootstrap servers to a database location at the database port 1521. And there's no change. So your producer dot send, can send it to a topic, and the code goes like it was going earlier. So this is how you would take a Kafka Java client and produce to AQ sharded queues or TEQ. Similarly, a consumer, right? Again, the consumer has a Bootstrap server. It has a group ID, which is basically the topic, and consumers subscribe to these two arrays, foo and bar, and then you kind of start consuming with consumer polling in some ways, right? And this code again becomes very similar, where you are now changing the Kafka broker to a database endpoint to 1521, and then again consuming the subscribe to this topic, and you are then consuming consumer polling, right? So in some ways, very simple changes to your producer and consumer. So something to keep in mind is, similar to AQGMS, if you're familiar with AQ and and Kafka models, we do need customers to download a kafka.jar file. So this is where some of the APIs are implemented. This means producer and consumer code changes to the import statement, like we showed, and also for property change. But some changes on property and setup are needed. And another idea would be run the Kafka wire protocol for this in the future. But that's something that we have to think about a little more. So to summarize, hopefully you got an idea of how the data in motion, events, messages are part of the Converged Oracle database to build modern applications. So if you are using AQ today, you should be thinking about AQ sharded queues, which are more performant. AQ sharded queues are available in database 19c. So use these when you upgrade to database 19c. So if you're on 12.1, 12.2, you should upgrade to 19c and get some of the stability, some of the new features in sharded queues. And as for performance, if you're on a DBCS node, we've observed AQ to be around the 400 million, 500 million messages per day type of capacity, because they are basically working out of disk. And AQ sharded queues or transactional event queues have been optimized to work out of memory, right? So there's a lot of caching going on, a lot of memory optimizations going on, a lot of latching in the memory going on, right? So they're partition queues, so for up to maybe 4 billion messages a day, right? You can basically see that you get about anywhere from 5x to 8x better performance than AQ because of the optimizations in memory. And of course, you can expect much better performance on Exadata hardware with better CPUs, more memory, and maybe even persistent memory type of things on X810, for example. Right. So again, hopefully this kind of covers the fact that messaging is part of the Converged database, and we are putting in a Kafka compatible client, right? So you can, if you're using Kafka, and yet you need kind of to use database events, or you need to use transactional messaging, you can use AQ and TEQ. So thank you for your time. Please reach out if you have any questions. My name is Sanjay Goil again, and my email is sanjay.goil@oracle.com. Right. So thank you for coming, and have a good rest of your day.